Hi, my name is Berkay and here I am with another video. In this video, I am going to show you how to use spectrogram to analyze your MP3 data, and after that I am going to show you how to design your two-stage FLR bandpass filter, and then we are going to do some quality checks on those filters to see them if they are working correctly or not. And lastly, we are going to filter out our MP3 data. Let's start. First, I have found this MP3 data in this website, and if you are interested in bird recordings, you can also check out this website. Now, let's see what's in this data. So, as you can see, it has two components. One is the sampling frequency, and it's equal to 44,100, and it has a signal, and it's equal to it has two channels. Now let's hear this recording. Now you can clearly hear somebody singing in this recording, but you can also hear another bird singing in the background and some noises. So we are going to filter out all those noises and that bird singing out of our recording. And in the end of this video, you will only going to hear somebody singing. But first, I need to analyze this recording, and I'm going to use spectrogram for it. I have specified my signal and its channel I am going to use. My hum windowing, after that overlap number, and this one is blank, and this is corresponds to size of my for a transform. It's not important, and my sampling frequency. Now I am going to show you spectrogram of this recording, and we are going to hear our recording again. Now those are where the somebody is singing, and those are that other bird, and those are just noises. Now I need the which frequencies between somebody is singing to create my bandpass filter, two-stage bandpass filter. So I am going to zoom in, and I am going to choose my cutoff low frequency as 4,900, and my cutoff high frequency as 6,500. And in here I have specified them. My cutoff low frequency is 4,900. It is for my high pass filter, and my cutoff high frequency is 6,500, and it is for my low pass filters. And in here I specified my Nyquist frequency, and it is equal to half of my sampling frequency. And I have created order of my filters in here. This is my high pass filters order, and this is my low pass filters order. Let's do that. Okay, and in here I have created my high pass filter scanner and my low pass filter scanner, and those are basically my filters. I have used FR1 function, specified my high pass filters order and its cutoff frequency, and that frequency is divided by Nyquist frequency, and type of my filter. And I have done the same in here. I have specified my low pass filters order, its cutoff frequency, and its filter type. Now I have created my filters and I need to do a quality check for them. And how I am going to do that? First, I am going to look the time domain response and frequency domain response. To find the frequency domain response, first I need to find the power spectrum. In here, I have calculated my high pass filter scanner's power spectrum and low pass filter scanner's power spectrum in here. And I have specified a different time vectors for my uh, power spectrum of my cannons because they have different length. And in here, I am going to plot them and let's see. Now, this is the time domain response of my high pass filter, and this is the frequency domain response of that filter, and this is the time domain response of my low pass filter, and this is the time domain response, frequency domain response of my low pass filter. And as you can see, my high pass filter lets everything to pass after 4900, and my low pass filter won't permit to anything to pass that greater than 600 and 500, 6500. And in here, as you can see, my frequency response of my filters are good, and I can use them to filter out my audio. Now I am going to use filter function to filter out my signal. First, I am going to use my high pass filter, and then I'm going to specify my signal. And after that, I am going to use filter function again. Now I am going to use my low pass filter, and I am going to use filter out signal. And in here, I have calculated the spectrogram of filter signal, and let's hear our filter signal. As you can see, we have only somber tits singing in this recording, this filter signal, and this is it. Thank you for listening to me.